Section 6 is on radicals. So first thing, we're going to start off with how we rewrite rational exponents as a radical. So last section we had rational exponents, something like a to the 1 over n. If we want to use radical notation, we're going to use that root notation, and to identify which root it is, we put the n, whatever the root is, right there in the notation. Okay, so a to the 1 over n can be written as the nth root of a. So in words you would say nth root of a. So if we had a to the 1/5, we would write that as the 5th root of a. So let's take this example, negative x to the 5/3, and rewrite that in radical notation. So let's look first at the root part. So whatever root it is coming from the denominator of that rational exponent. So that's a 3. So this is going to be a 3rd root. And then we take whatever the base is, and in this case it's this negative x. We want that in parentheses, and we want to apply whatever the exponent is. So the exponent is the numerator. So that 5 goes as an exponent on that negative x. Let's look at another one. This time we have a base of 3a minus 2b with rational exponent of 3/4. We want to rewrite that using radical notation. So start off with what the root is. So that's what's in the denominator. It's the 4. All right, so we just take that 4 that's in the denominator. That's what the root is. Then the base goes under the radical, keeping it in parentheses, 3a minus 2b. And then the exponent is the numerator. So we want to put that as the exponent on that base. Okay, so we end up with the 4th root of 3a minus 2b, that quantity squared. Now let's go the other direction. Let's say we have negative 3 cube root, or 3rd root of 2 x to the 4th. Okay, so we're wanting to translate the root to a rational exponent with that root, in this case 3, in the denominator, and then whatever has a exponent underneath the radical, we want to include in the numerator of the rational exponent. So the negative 3 is kind of outside of the radical, so it just kind of comes along and isn't going to have any kind of rational exponent on it. So the 2x to the 4th, that's the part that's under that cube root. So that whole thing has a rational exponent of 1/3. Right, we want to write this without parentheses, so we'll keep that negative 3. If we distribute that exponent of 1/3, we can write that as times 2 to the 1/3, and then distributing it to the x to the 4th, where we're going to multiply the 4 and the 1/3, we get x to the 4/3. And we now have converted that radical to an expression with rational exponents. Okay, now we are going to look at when we want to simplify some radicals. So let's just start off with the square root of 50. So our goal in simplifying radicals is to write so that there is the smallest possible number underneath the radical. So what we want to do is we want to take out any factors that we be able to take the square root of. So we want to factor the 50 and factor it such that one of the factors is a perfect square or something that's squared. So 50 is going to factor as 25 times 2. Now with radicals, we can break them up if they're multiplied and write that as square root of 25 times the square root of 2. We can simplify that square root of 25 as 5. So we end up with 5 times the square root of 2. Now let's look at one with a cube root. Let's take the cube root of 128. Okay, so the trick here is how can we factor 128 so that one of the factors is a perfect cube or some number cubed? Well, if we factor this as 64 times 2, we can then rewrite that as the cube root of 64 times the cube root of 2. And then the cube root of 64 is 4. And then that's times the cube root of 2. Okay, we're going to keep with simplifying. We're now going to add variables to the mix. Let's take the square root of 162, x to the 5th, y to the 6th. Okay, so this is just square root. We're going to apply the same principle where we're going to try to find factors of each of the bases inside the square root that are perfect squares. So 162 we can write as 81 times 2. And the x to the 5th, we can write that as several bases of x by kind of breaking apart that 5 so that we have x squared times x squared times x to the 1. If we go the opposite direction and kind of add up those exponents, we get back to that exponent of 5. All right, same thing for the y's. If we write that as y squared, y squared, y squared, all right, if we add those 2's back up, we get to the y to the 6th. Okay, so we can write this as square root of 81 times the square root of 2, and then square root of x squared, square root of x squared, square root of x, and then square root of y squared, square root of y squared, square root of y squared. Now, going through and simplifying, square root of 81 is a 9. Then the square root of 2 stays like it is. Square root of x is just x, and then another square root of x, right? So we got square root of x squared equals that x, square root of x squared equals that x. And then square root of x just stays as it is. Okay, we can't do any simplifying there. Then we take those square root of y squareds, and those are all going to simplify to just a y. Now, we want to write all of the things that are outside of the square root out in front, and then combine the things that are under the square root for one square root. So we've got a 9, and then we have x times x, so that's an x squared, and then y times y times y, so that's a y to the 3rd, or y cubed. And then the things that are under the square root are the 2 and the x, and so we can write those together underneath the square root. Okay, now let's take when we have several terms with radicals and we want to combine them with addition and subtraction. So the rule here is you can only combine the terms with the same radical. So the same number underneath the radical. Okay, so as they are, we cannot combine them. We may need to simplify first. So let's take that square root of 8. So we're wanting to think of factors of 8 such that one of them is a perfect square. So we've got 4. And then the next term, 32, we can write that as 16 times 2. And then the next one, we can write that 18 as 9 times 2. So going through and simplifying, we're going to have 2 times, taking that square root of 4, that simplifies to a 2, and then we're left with the 2 underneath the square root. Then we have plus 3. Square root of 16 gives us a 4 outside of the square root, and we're left with 2 under the square root. And then the next term, square root of 9, will give us a 3 out in front of the square root, and again we're left with a square root of 2 underneath the square root. Okay, so you notice that when I pulled those terms out from under the square root that simplified, I just multiplied by the coefficient that was out in front. So let's go through and do that multiplication. So we get 2 times 2 is 4 times square root 2. And then 3 times 4, we get 12 square root 2. And then minus 2 times 3, we get 6 square root 2. So because each of these terms have the same radical, the same number underneath the square root, we are going to be able to combine these by adding or subtracting those coefficients. So we're going to get 4 plus 12, which is 16 minus 6, we get 10 square root 2. All right, we can do the same thing with cube roots. So let's take this one, 5 times cube root 3 plus 3 times cube root 24 minus cube root of 81. So we want to simplify where we can. First one, there's nothing to simplify there. 3 is not a perfect cube, so that just stays like it is. And if we look at the 24, we can factor that as 8 times 3, where 8 is the perfect cube. And cube root of 81, we can factor that 81 as 27 times 3, where 27 is a perfect cube. Okay, so let's go through and simplify now. So that 5 cube root 3, make that look more like we're writing a cube root. There we go. Nothing we can do there. We can pull out a 2 for the cube root 8, and then we're left with a cube root of 3. And we can pull out a 3 for the cube root of 27, and we're left with cube root of 3. Okay, now we have all the same thing underneath the radical, so we can combine these by just doing addition and subtraction. All right, so first let's just do this 3 times 2, that's a 6 for that coefficient. All right, so we get 5 plus 6, which is 11, minus 3, we end up with 8 cube root 3. Okay, that's adding radicals. Let's look now at multiplying. So let's take square root of 5 plus 5 times square root of 5 minus 5. So each of these has 2 terms. So to multiply, we can use FOIL. All right, so we take the first times the first, and that we're going to get square root of 5 times the square root of 5. And let's just keep going with that. Whenever we multiply a square root of something by itself, well, that's squaring, and that just undoes the square root. So it's just going to equal what's underneath the square root. Okay, so that's the first term. Okay, the second, or I'm sorry, that's the first times first. Now we take the outer times the outer, so we're going to get minus 5 square root 5. And now inner times inner, or inner, multiplying these ones, we get plus 5 square root 5. All right, so those two actually cancel each other out. And now we multiply last times last, so we get a minus 25. All right, so we had the 5 from square root 5 times itself, and now we have a minus 25. So combining those, we get a minus 20. All right, let's look at another one. Let's take got the square root of 7 plus the square root of 50, that whole quantity squared. Now remember, this is not a case where we can distribute that exponent of 2 because we've got this plus combining the square root 7 and the square root 50. Those are in relation to each other. Those are not factors. So we cannot distribute that. But we need to remember what this is the square root 7 plus the square root 50 times itself. So we can rewrite that as something that we can apply FOIL to. So multiplying the square root 7 times square root 7, that just gives us a 7. Square root 7 times square root 50, I'm just going to write that as, I'm not going to try to do that multiplication. We'll come back to that. Let's just write it like that. All right, so that was the outer. And now we do the inner, and we're going to get another term that's identical to that. So plus square root 7, square root 50. And then the last term, square root 50 times itself, so that's just a plus 50. Okay, simplifying what we have here, we can add the 50 and the 7 for 57. Now, we've got this square root 50, which let's just rewrite that because that's got a perfect square as a factor. All right, and then we have another one of those. So we have 57 plus square root 7 times square root 25, it's just a 5, and then times the square root 2, and then we got another one of those. Let's see, I need to go back here. This should have been a 7. There we go. And so we have square root 7, simplifying that square root of 25, we get a 5, and then times the square root 2. Okay, so we got 57, and then plus 5 times, we can multiply these two square roots together, and we end up with the square root of 14. Okay, same thing for this other term. We have the 5 outside of the square root, multiplying the 7 and the 2, we get 14. And then finally, because we have the same thing under the square root, we can actually combine those terms by adding those 5s. And we get plus 10 square root 14. Okay, the last thing that we're going to look at with radicals is rationalizing. And we want to rationalize the denominator. So that just means we want to make the denominator a rational number. In other words, we want to get rid of the radical. So we obviously can't just take it away. We have to manipulate it somehow. So let's look at how we do that. Okay, let's take this example. We're going to have a negative square root of 25 over 3. Okay, so the negative is just going to stay out in front. We can break that square root up onto the numerator, and so make that square root of 25, and on the denominator, so that becomes square root 3. So the numerator simplifies to 5, but that denominator stays having a square root. So we want to be able to get rid of that square root. We can't just take it away. We have to manipulate it somehow. So what we do is we multiply by that square root 3. If we multiply the bottom by square root 3, we have to multiply the top by square root 3, because then it becomes just multiplying by 1. So we choose that square root 3 because when we multiply square root 3 by itself, that just becomes 3, whatever's underneath the square root. And then the numerator, we get 5 times square root 3, like that. So we end up with negative 5 square root 3 over 3, and we've gotten rid of the radical in the denominator. It's okay if there's a radical in the numerator. Let's look at another one. Okay, this time we're going to have square root 3 in the numerator, and in the denominator we're going to actually have an expression that includes 2 radicals combined with addition. So again, we have to pick the right thing to multiply by. top and bottom, to get rid of that radical. So what we choose is called the conjugate of that expression, square root 5 plus square root 2. And the conjugate is just going to be the expression that includes those same exact radicals. The only thing is we're going to change the sign that combines them, changing it from addition to subtraction. And that's going to guarantee that we're going to get rid of the radicals, and we'll show how that happens. Need to also multiply the numerator by square root 5 minus square root 2. Okay, there are implied parentheses around these expressions, all of these. So next step is we go to multiply. In the numerator, we are going to distribute that square root 3. So square root 3 times square root 5. We multiply the 3 and the 5, and we get square root 15. Multiplying square root 3 times a negative square root 2, we get negative square root 6. That takes care of the numerator. Okay, now in the denominator, we're multiplying two things that have two terms, so we can use FOIL. So the first term times the first term, so square root 5 times itself, well, that's just going to be 5. And then we take the outer terms, square root 5 times a negative square root 2. Well, that's a negative square root 10, just multiplying the 2 and the 5. Now let's look at the inner terms. So that's going to be square root 2 times square root 5. Well, that's going to be a plus square root 10. And then finally multiplying the last term by the last term. So we get square root 2 times square root 2. Actually, that's a square root 2 times a negative square root 2, so that's going to end up being a minus 2. Okay, so let's look at what we end up with. The numerator, we have square root 15 minus square root 6. That's simplified as it can be. Now you'll notice that this minus square root 10 and the plus square root 10 cancel each other out. Okay, so that's guaranteed to happen by choosing to multiply by that conjugate. Now we just combine the 5 minus 2. That gives us a 3 in the denominator, which is rationalized. There's no radical. Okay, next example. We have got 3x over 1 minus, and here's the radical that we're going to need to rationalize, square root of x plus y. Okay, so it looks a little different than the previous one, but we're going to apply the same principle. We want to multiply by the conjugate of what's in the denominator. So the two terms in the denominator are 1 and the square root of x plus y. And we want to change the sign in between them. It was minus, so we want to put in a plus. And we multiply the top by that as well. So we got parentheses around these quantities. And the next step is we go to multiply. So we're going to distribute the 3x in the numerator. So we get 3x plus 3x square root x plus y. In the denominator, we're going to use FOIL. So first times first, we get 1. Outer times outer, we get a plus square root x plus y. Inner times inner, we get a minus square root x plus y. And then last times last, we get a minus, in parentheses, x plus y. Right? Because we have square root x plus y times square root x plus y. And that's going to give us just what's underneath the square root, so x plus y. And then the minus is applied to that whole thing, so we want to make sure that we distribute that minus. Okay, so simplifying, numerator stays the same, 3x plus 3x square root x plus y. In the denominator, the plus square root x plus y cancels with a minus square root x plus y, and we've got a 1, and then distributing that negative, we have a minus x minus y.